This is 13.5, day 1, the law of sines. Our objectives are to determine the area of a triangle given side angle sides, and using the law of sines to find lengths and sides of angles in a triangle. You don't need to write these objectives down. This first slide, equations for the law of sines. I do want you to write down that when you can use the law of sines, when you have angle side angle, or an angle side. What the law of sines does is allows you to find the missing side length or the angle measure in a triangle. So here are the equations for the law of sines. Just go ahead and write down one of these two boxes, either this blue one or this red one. They are the same thing. So you have the sine of A over A equals the sine of B over B equals the sine of C over C. And you just choose 2 out of those 3 fractions and you set them equal to each other and solve for the missing side length or angle measure. And then I have a picture drawn below here. I don't need you to write this down, but what you're going to have is an angle, a side, and then possibly another angle, and then you'd want to solve for this missing side. So you'd set up an equation that looks like this. The sine of B over B equals the sine of A over A. And we're going to use cross multiplication and then solve for that missing side B. So here's our first question. Go ahead and write this example down. We're given this triangle below. Find the side lengths of A, B, and C and the angle measure for B. So we are given angle 40 degrees and then side opposite, which is side A, is 20 units in length. Then side C is unknown, side B is unknown. So let's start with the first thing, angle B. Angle B, we can use the triangle sum theorem. The triangle sum theorem, if you remember, is the 3 angles in a triangle add up to 180 degrees. So we say 180 degrees minus angle A, which is 40 degrees, minus angle C, which is 49 degrees. And then we solve for angle B. And we get 91 degrees. So now let's come back over to here and identify that angle, 91 degrees. Now we want to find the side lengths, A, B, and C. So we're going to use the law of sines. So let's go ahead and find side C first. Side C, we set up a equation set, say the sine of A over A equals the sine of C over C. And then we substitute in the pieces that we know. The angle A is 40 degrees. So we say the sine of 40 degrees over A, which is 20 units, equals the sine of C, 49 degrees, over our unknown side C. Now we have a fraction on the left and a fraction on the right, so we use cross multiplication. So we say C times the sine of 40 degrees equals 20 times the sine of 49 degrees. Kind of got squished, so I'll just write it off to the side a little bit more. So C times the sine of 40 degrees equals 20 times the sine of 49 degrees. Now we solve for C, so I'm just going to divide both sides by the sine of 40 degrees. now we have C by itself. Now you need to use your calculator. 20 times the sine of 49 degrees is 15.09. The sine of 40 degrees is 0.6427. And now divide those two numbers. 15.09 divided by 6.427 is C is approximately 23 and a half. We'll just round it to the nearest decimal place there. So we'll go back up to our picture and identify that as 23.5. Now let's find our last piece, side B. So we say the sine of A over A equals the sine of B over B. And then substitute in what we know. Angle A is 40 degrees. Side A is 20. The sine of B is 91 degrees. And then side of B is unknown. And then we use cross multiplication again. So B times the sine of 40 degrees, and then 20 times the sine of 91 degrees. Then divide both sides by the sine of 40 degrees. Alright, so now use your calculator. 20 times the sine of 91 is 19.99 divided by the sine of 40, which is 0.6427. Divide those two numbers, and you get B to be approximately 31.1. All right, let's go on to this example. Here's a triangle ABC, and we're given the angle A is 32 degrees, side AB is 8, and then side BC is 5. And we want to find the missing angle, C. This is our unknown, so we're going to use the law of sines. So we set up a proportion. The sine of A over A equals the sine of C over C. Well, angle A is 32 degrees. Side A is 5 equals the sine of C, C is our unknown, over side C, which is 8. Use cross multiplication. So 8 times the sine of 32 degrees equals 5 times the sine of C. And then we want to get that sine of C by itself, so we divide both sides by 5. So 8 times the sine of 32 degrees over 5 equals the sine of C. So I'm going to just simplify that fraction. 8 times the sine of 32 degrees is 4.239 divided by 5. And you get a decimal of 0.8478 equals the sine of C. Now we need to use inverse trigonometry to solve for the angle measure. So we say C equals the sine inverse of 0.8478. So second sine of 0.8478 is C is approximately 58 degrees. I just round up to the closest degree measure. I'm going to stop recording there and we'll pick up with our next recording.